So we left off at the last video of multiplying in a received input and the VCO output together and putting them through a low-pass filter. And then previously too, we saw what a VCO might look like. Oops, this should be gone. And we saw that our VCO would have a output signal that looked like this. So we've seen what would happen if we multiplied those two together, and we kind of saw where this VCO came from. But we still haven't really learned anything about this, except for that the VCO output is based on that signal. So we're going to need to find a way to loop this in so that we can put this all together as a control system. So the phase lock loop is going to have some other loop filter that's defined by a transfer function, and you can define that in time domain or the S domain. And then the loop filter, it's going to need to give us an output signal. Okay, so whatever we do, the filter of this is what we want from that is this signal, right? This is the one that we said is going to go back and go into our VCO. Okay, so the loop filter should take in that multiplied signal that passed through a low-pass filter, and it should give us out some E0 signal that we're going to supply to the VCO. So if we supply that signal to the VCO, and we assume that this is a linear system, then we see that, right, this is going to be the convolution of these two, right? We're going to need to take the convolution of the input. So we're going to take the convolution of the input and the transfer function to get this as the output. Using the definition of convolution, we can apply it, and we're going to be integrating from 0 to time, and then inside of this, we're going to have this dummy variable x and our transfer function here. We have another expression, however, that already contains our E0. Right, so because we already assumed that this was going to be going into our VCO input, we already have an expression that contains the E0, or the EO, and that's the derivative of the VCO output phase. So if we substitute that in, we can now multiply C by this. So we can take this whole term, put it into here, and then that gives us this whole thing here. Now we can make another simplification where we define the phase error. So we'll define the phase error as the difference between the input phase and the output phase. So this is the difference between the input phase that was received into our system. And recall, right, the input phase, right, this was defined based on some different input frequency that was different from the VCO free running frequency, and the output phase, which was the integration of this signal. So we'll define the phase error as the difference between these two different phases. And then we're going to pull some of these constants out front, right? So we're going to take these ones, pull them all out front. This constant C is related to the VCO's linearity, B is the VCO signal amplitude, and A is the received signal amplitude. The phase lock loop filter now is going to look like this. We're going to have some output that was the convolution of those two terms, and we're going to be able to see that the output to our loop filter could be given as the derivative of the VCO output phase, or as this convolution definition. So now we have a full system that we can put together where basically we have some received signal, right? This is some signal you receive. This input is based off of whatever frequency that was actually received, and we cleverly rewrote it to contain the VCO free running frequency. And then our VCO output contains the VCO free running frequency plus some output phase, and that output phase is the integration of this input. Okay, so this is the input, and basically the voltage controlled oscillator is going to integrate the output of the loop filter and pass it through, and it's going to come out as your output phase. And so that's why this thing, it's important, right here, right, we're going to compare these two. and then that passes through the loop filter, and then out of the loop filter you're going to get some difference between these two, pass it through this VCO, and in this way we're going to be able to use the loop filter and the voltage controlled oscillator in a type of feedback system. And so, as I mentioned in the beginning of this, right, we're going to approach this from a little bit of a minor controls theory perspective, but since it's not a controls theory class, we won't cover all the control theory details.